Hello and welcome back to our series on statistical methods and data analysis. In our previous two videos, we looked at graphically displaying and describing categorical data and the graphical display of numerical data using a stem and leaf plot. Today we're going to look at graphically displaying histograms. These are another graphical method that we can use that will aid us in describing data. Now, histograms are very similar to frequency and relative frequency plots. However, these have numerical data instead of categorical data. I'd like to return to our height data that we looked at with our stem and leaf plot. And remember, this height data has been rounded to the nearest centimeter. The first thing we need to do when we create a histogram is determine how many categories or bins we will have. In order to do this, we're going to take the square root of the sample size. Now, in the case of our height data, there are 39 observations. So when we take the square root of 39, we get 6.22, which is approximately 6. This can be rounded down to 6 or up to 7. The width of our bins, our categories, is just the maximum value minus the minimum value divided by how many bins we're going to have. This will keep us with equal bin width. Now, in our case, our maximum value is 179. Our minimum value is 122. If we divide by 6, we get 57 divided by 6, which is 9.5. Now, we can use 9.5, and we'll see an example of the use of 9.5, or we can round up to 10 for ease. Now, you can also do relative frequency histograms as well as frequency histograms. The ones I've created in these slides are frequency histograms. First, let's take a look at how we're going to get our counts in our bins. We're going to use a bin width of 9.5. Now, let's start at 120, and we'll go to 129.5. And in that bin, there is one count. From 129.5 to 139, there is one count. From 139 to 148.5, there are 6. From 148.5 to 158, there are 15. From 158 to 167.5, there are 12. From 167.5 to 176, there are 3. And from 176 to 185.5, there is 1. Notice, each of these bins has a width of 9.5. Also notice, this first bin goes from 120 to 129.5. And the second bin starts at 129.5 and goes to 139. And notice that the ending point on each bin is the beginning point on the next bin. This is because this is continuous data. And so in this particular bin, I'm going to go up to 129.5, but I'm never going to quite get there. With our histograms, unlike with our bar charts, our bars will connect. And we'll see an example of this in a few minutes. Now, let's also take a look at what happens if we use a bin width of 10. Here, I've gone from 120 to 130, 130 to 140, 140 to 150, and so on. And notice in my first bin, there are 2. My second bin, there is 1. My third bin, there are 11. My fourth bin, there are 13. My fifth bin, there are 9. My sixth bin, there are 3. Now, how am I getting these? Well, I'm simply looking at the data and counting the number that fall within each bin. Now, I need to plot the counts in each of these bins, and these are known as histograms. Again, notice, my bins are touching. Each one of these bins touches, unlike with my bar charts where they were separate categories. So what can we learn from graphical methods such as a histogram or a stem and leaf plot? Well, we're going to leave that for our next video. However, how might we do this in R? Well, I'd like to take a look at finding this by hand first. Here's our height data. And so I need to find the number of categories. I want to take the square root of the sample size. Well, first I need to run my data. And so I've run my height data. And in this case, since this is simply a vector, I can look at the length of this data set as n. And what I'll see is that n is 39. And so the number of my categories is going to be the square root of n. And we can see that the number of categories then, 6.244998. Now, as I said earlier, we can round down to the lower integer or round up to the higher integer to get our number of categories. So I'm going to call ncat L. That's going to be rounding down to 6. And I'm going to call ncat U, rounding up to 7. Now I need to determine the bin width of the intervals. Again, that is the maximum minus the minimum divided by the number of categories. So I'll call bin width L. That will be the bin width that I use with my lower rounding. And so that bin width, 9.5. But what happens if I round up to 7 instead? Well, if I round up to 7, now my bin width is 8.14. And so what would I do? Well, I need to count the number of observations falling within the bin width. So how do I count the number of observations falling within the bin width? Well, let's sort the data. And as you can see, our data is sorted from 122 to 179. I simply need to look at how I'm going to set up my bins. Well, I could say, let's start at 122. And so my first bin would be 122 to 131.5. That's 9.5. There are 2 that fall in this. And then my second bin, 131.5 to 141, there's 1 that falls in. My third bin goes from 141 to 150.5. And as you can see, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values in this bin. From 150.5 to 160, now I look, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values. My fifth bin, 160 to 169.5, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 169.5 to 179, there are 2. And then at 179, there is 1. Well, suppose instead I take my bin width of 8.14, that was using our upper rounding for our number. I round this to 9, and now I have 2 units in my first bin. I go from 122 to 131, and then 131 to 140, there's 1. 140 to 149, there are 11. 149 to 158, there are 9. 158 to 167, there are 12. 167 to 176, there are 3, and 177 to 186, there is 1. But recall, I said we could take that 9.5 and round up to 10. Well, let's make it easy on ourselves, and we'll start at 120. So our first bin is going to go from 120 to 130. Well, there are 2 that fall in that bin. Here they are. And 130 to 140, there's 1. And 140 to 150, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 150 to 160, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And 160 to 170, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 170 to 180, there are 3. Now, this particular method is how R is going to create this histogram. In either case, once we have determined how many bins we have, we simply need to plot the counts in each bin by drawing a rectangle whose height is at the number of counts per bin. How can we do this if we're using R? Well, we're going to use the histogram function, hist. And notice I'm applying the hist function to my data, height 2. I've labeled my x-axis heights in centimeter. I've labeled my y-axis frequency of occurrence. And let's see what it looks like. And here is my histogram. Notice I've drawn a rectangle at the height of each number of counts in the bin. And also notice that my bins touch. But what if I wanted to do a relative frequency histogram in R? I simply use the same method that I used to create a relative frequency bar chart. I divide the counts in each bin by the total number of observations in the data set. Now, if I would like to do a relative frequency histogram, I'm going to call this H, and that's a histogram of my data, but I put plot equals false. That way the plot doesn't show up. Now, $counts is going to represent the proportion of counts within each bin. So I'm going to take the counts, I'm going to divide it by the sum of all my counts. Now I can plot my data. I'm going to plot H. My frequency is true. I now have labeled my X and Y axes. Notice what I have. I have proportions here. Now if I look at my $counts, I simply need to multiply these by 100% to get my relative frequency. So if I look at $counts and I multiply that by 100, I get 5.12%, 2.56%, 28.20%, 38.46%, 17.94%, and 7.69%. Okay, that's it for this video. In our next video, we will begin describing shapes of distributions. See you then.